Good afternoon, everybody. Dear student, today again we are here to learn something new, and today's topic is molecular formula. So, it may be it may not be new to you, but you have already studied in lower class about the molecular formula, and we have studied already about what is molecule. Okay. So, we already know that molecule is the simplest or the smallest unit of element which exists independently or freely in nature or environment. Okay. So, about that we have already discussed, and that also we have taught, we have learned that there are monoatomic element as well as diatomic element like chlorine, bromine, iodine, which we have already discussed that they exist in diatoms, that in the form of Cl2. So, Cl2. So, it is a diatomic element, okay, which exists in the nature in Cl2 form. It cannot exist in the form of Cl. Similarly, carbon, we can say it is a monoatomic element. So, carbon can be found or exist in nature in the same as C, like in the diamond or graphite, isn't it? So, what happened? There are different element or the molecule which exist in the nature independently. So, they are molecule, and we already know that, and we have discussed many times about the electronic configuration, about the inert gases, isn't it? So, what happened? All the element, they wants to get stable electronic configuration, and there we have discussed about the valency, that is the tendency to gain, lose or share the electron to become stable. And we have discussed about the radicals. Okay? Radicals, group of element or atom combined together and carrying out either positive charge or negative charge on them, they are called radicals. Similarly, we have studied about the cation and anion. So, all together if we talk about it, all the element, they wants to be stable, and hence they are forming a compound. Okay? And we have studied about the ionic bond, covalent bond and coordinate bond, how they come closer to each other, how they are bonded, or they come closer to each other, and they have a force, either electrostatic force or a molecular force which is existing between them, which make them together. Okay. So, how this compound are formed directly or indirectly related to their valencies. Okay. It is related to their valencies. So, it is very much important for us to know how to get the valency of different element. For that, electronic configuration is necessary. So, you already know how we can find electronic configuration by knowing the atomic number and arranging them in different cell like 2n square rule, etc. Okay. So, here today we are going to learn what are the different rules, what are the steps or the method or the procedure by which we will form a compound or a molecule and giving their name, how they have different types of name, and name is given with the formula. Okay. Now, what is formula, or what do you understand by molecular formula? So, we know that molecule is the smallest particle which can exist independently in nature. Okay. Smallest form of an element which exists independently in nature. Okay. So, if we want them to exist independently in nature, this molecule, they have to come in contact with different element. Yes, except inert element, all other element do not have stable electronic configuration. So, they may have covalent bond or ionic bond. Okay. So, for writing the molecular formula, first we have to know what is molecular formula. So, molecular formula is the symbolic representation or short form of the name of the molecule, okay, by which it is made up of. Okay. Symbol, short form. In short form, how we will represent them, how we will write them by using their symbols of atom which involve in the formation of a molecule, that is known as the molecular formula. Okay. For example, if I write hydrogen chloride, okay, hydrochloric acid, okay, we call it as hydrogen chloride. Okay. So, hydrogen chloride is formed, or hydrochloric acid is formed of two atom or two element, that is hydrogen and chlorine. So, two element are involved in the formation of hydrogen chloride. So, we have written in the word, if same thing, if we can represent by using the symbols of the respective element which are involved in it, then we will call it as a molecular formula. For example, hydrochloric acid, it is formed of two elements, that is hydrogen, okay, and another one is chlorine, okay, or hydrogen chloride, IDE. We have already talked how when radical loose and bond forms ionic bond, okay, that is HCl, and sharing how it is formed, we have already talked about. So, hydrogen chloride, here hydrogen is denoted by a symbol H and chlorine Cl. Now comes the role of valency. So, how much they are contributing electron with each other, either maybe of sharing or by transferring of electron. We have already discussed what type of compound is the HCl. Okay. So, now we should know what is the valency of hydrogen and what is the valency of chlorine or chloride ion. Okay. So, we know already we have discussed that valency of hydrogen is 1. So, generally it is written as the subscript of the element, and chlorine is at the it also has valency 1, because at the outermost shell has 7 electron and requires 1 more electron. So, what happens in this way, if there is crisscross method, we have already discussed in lower classes, still same thing we will discuss here again, that is HCl is formed. This is the short form in which we have written a name or symbol representation of hydrochloric acid or HCl, hydrogen chloride. Okay. So, that is about the hydrogen chloride, hydrochloric acid. So, this is the short form of the name of molecule hydrogen chloride. Okay. So, now in any method we cannot write, there are some steps to be followed while writing the molecular formula. Okay. So, first of all, here while formation of compound or molecule, okay, so molecule here molecule, there is involvement of two radicals, okay, two identities, one act as a positive radical and another act as a negative radical. So, while writing the molecular formula, we should be aware that we in the left side at the first we should always write positive radical, and in the right side we should write negative radical. Okay. That is, first toward the left we should write positive radical, and on the right we should write negative radical. So, that is the first thing that we have to keep, we have to take care of. Okay. So, we will start with the step wise. So, first what we have to do, first while writing the molecular formula, first step should be while writing the molecular formula, while writing the formula, electropositive radical, or you can say electropositive radical, okay, electropositive radical should be written at the left, written at the left, okay, at the left, while electronegative should be written at right side. Okay, is it clear? Right. Okay, it should be written at right, electronegative. So, like earlier in case HCl, Cl, that is chloride ion, we have written in the right hand side, hydrogen positive charged, or it is contributing electron to each other. So, that is we have written as the at the left hand side, at the first. So, positive radical and negative radical. Okay. So, second step is that, what we have to do first, while writing the formula, electropositive radical should be written first, its symbol should be written first. After that, the valency of both the radical should be written at the top of symbol, otherwise what we can say, at the superscript, we can write. Okay. After step 2, in step 3 we have to apply criss-cross method. What? Criss-cross. So, what we have to do? Criss-cross the valency. Okay. We will discuss with the example. Criss-cross should be done, should be carried out of valencies. Okay, should be carried of valencies. So, criss-cross should be carried out. Okay, we should do criss-cross of the valencies to get the formula of the molecule. Okay, so that is clear. So, if other step is that, after doing the criss-cross method, if there is some common, okay, then what we have to do? We have to divide that number, okay, that SCF, whatever the common will be there in that their valency, we have to divide by that number and remove it. Okay. So, after if there is a common factor with them, so we have to remove common factor. Common factor of valencies should be divided. So, we have to divide it. Okay, should be divided. Common factor, by that we have to divide. Okay. So, that is in the case of and we will write that in subscript. So, how we will write? After that we will write that subscript. We will write in subscript. Okay. Now, after doing this, if there is the compound radical is there, in case of compound radical, the whole compound radical will be written in the bracket. So, we will write in bracket compound radical is involved in the formation of a molecule. In that case, a whole radical is acting as a single unit. So, the valency contributing after criss-cross should be written at the after applying the brackets together. Okay. So, in this way, these are the procedure by which we will write the molecular formula. Okay. Let us see with the help of example. Okay. Step by step, let us see. Now, first I will take example of potassium. Okay, potassium sulfide. Potassium sulfide. So, there are two elements which are involved in the formation of this molecule. Okay. So, first of all we have to recognize which type of element are involved in it. So, molecular formula give us the idea of the atom or the element which are involved in the molecule. Okay. So, first we have to write the symbol of, okay, first system we have to write the symbol. Now, symbol we are writing. While writing symbol, what is the symbol of potassium? Potassium symbol is K. Okay. What is the symbol of potassium? It is K. Okay. Symbol is K, and that of sulphide is S. Okay. And now we should know or we should remember what is the valency of particular element which are involved. So, we already know that potassium valency is 1. Okay. Valency of potassium is 1. So, we will write at the top K 1. Okay. That is, here 1 is indicating as the valency. Okay. Similarly, in case of sulphide, okay, in case of sulphide, the valency of sulphide is 2. What is the valency of sulphide? It is 2. Okay. Now, what happens here, after writing this, second step was we have to find out whether the valencies have some common factor or not. Since 1 and 2 do not have highest common factor between them, okay, they do not have common valencies, we cannot divide by same, they are not common, they are not having any common. So, what we have to do? Now, we do not have to look that, now we have to crisscross, means this will go here in the what we can say in subscript, whereas this will go here in downscript, in subscript down, okay, at the K. So, in this way what we will write? We will write it as K 2 S 1. So, how we have written? This is the molecular formula K 2 S 1. So, 1 simply we can remove it and we can write simply K 2 S. So, this is the molecular formula of potassium sulphide. Is it clear? So, this is the symbol of potassium sulphide. Now, let us take the another example of calcium carbonate. Calcium carbonate. Okay. Now, there is compound radical involved as well as one simple or radical. Okay. Simple radical is there. So, here what are the element or the radical? What are the different two radical which are involved, that we have to know. So, here calcium means symbol of calcium is Ca, and that of the carbonate is CO3. Okay. Carbonate is, what is the formula? CO3 radical. So, here we are not writing charge on it. Okay. We should not write here, though we should remember it is a it is requiring 2 electron to become stable as a whole radical, we have discussed earlier. Okay. So, what is the valency of calcium? Okay. What is the valency of calcium? It is 2. So, calcium valency is 2, and that of carbonate, what is the valency of carbonate? It is also 2. Okay. Valency of carbonate is also 2, and that of calcium is also 2. Now, here you can see calcium valency 2 and that of carbonate also 2. Now, there is a common. What is common between them? What is the HCF between them? That is 2. So, if we divide both of them with 2, what we will get? We will get 1 and 1. So, when we do cross also, we will write in this way, okay? We will cross, but SCF should be done, and after doing SCF, what is the remaining after dividing, what is left, we will write that. So, we can write here, it is as this also Ca2 CO3, then this 2, okay, this 2. So, here if we write 2 here, what does it indicate? Is this 2 for this only or for this only? There is a problem. Since this is a compound radical and it always act a single unit, this whole 2 means to both CO3. Okay. So, here this is 2 valency, this is also 2 valency, which is found after the crisscross method. So, already I have told we have to take SCF and divide that valency by that SCF to get it. So, here 2 will be cancelled out and SCF will remain 1. So, here its formula will be CaCO3. Okay. So, remember this is the molecular formula, 2 is there. So, it is cancelled out because 2 is the common factor between them, that HCF is there. So, we will remove it with that. So, this is the molecular formula of calcium carbonate, where a single radical, simple radical as well as compound radical are involved, and there we have to write, if compound radical is involved, we have to write that compound radical within the bracket to indicate that formula. Okay. So, similarly, like that of calcium hydroxide, suppose we are doing for calcium hydroxide. So, if we are finding out for calcium hydroxide, now which element are involved here? So, calcium and hydroxide, it is OH. Okay. OH minus, it is valency 1, calcium valency 2, we already know. Okay. So, calcium valency 2, that of hydroxide is 1. So, after doing crisscross, it will go here, it will go here. Is there any common factor there? No. So, we will write Ca what 1 and OH 2, but 2 is a compound radical. So, we will write here in bracket, and no need to write 1 here. So, we will do it as CaOH whole 2. So, this is the formula of calcium hydroxide. So, is it clear? Okay. So, in this way we can write the molecular formula of different element, okay, different element combined together. Okay. So, like this you have to practice the formation of different element combining together to form a molecule. There are lots of example in your exercise. Okay. We will practice it tomorrow also. Okay. We will discuss it more about just introduction today. So, we have to practice a lot to make easy to write. Okay. Always we have to practice. It is without practice we cannot do anything easily. So, at first it will find we will find difficult. As we go on learning like valencies, if we know valency, we know electronic configuration, then easily we can write the molecular formula by following the different steps. Okay. Now, please look at the slide. So, through the slide we will try to understand again. Okay. So, please play the slide. So, first of all we have to know what is molecule or molecular formula. So, before learning that we should know what is molecule. Okay. The smallest particle of an element or a compound which is capable of independent existence is known as the molecule. Okay. So, already I have told there are monoatomic element and diatomic element, some of the examples given there. So, hydrogen H2, O2 oxygen, nitrogen, iodide and chloride bromine. Okay. Chlorine bromine is given there. Similarly, molecules of compound also given like carbon dioxide, water, sodium chloride, hydrogen fluoride, etc. Okay. Now, sometimes this type of question is asked in your exam. What do you mean by H, 2H, H2 and 2H2? Okay, this is the question which are there in most of the exercise, okay, of different publication book. So, you have to be clear about it. So, what does H means? H represent only the atom of hydrogen. Okay. H, if it is written in your book or the exercise wherever you find in science, H capital letter will always represent hydrogen atom, whereas 2H means there are 2 hydrogen atom. Okay. And this H2, H with the subscript 2, it represent the molecule of hydrogen, H2 only. Okay. Only H2 represent the molecule of hydrogen, whereas 2H2, that is 2H subscript 2, that represent the 2 molecule of hydrogen. So, in nature hydrogen cannot exist in the form of simple H, it can only exist in the form of H2. So, during the chemical reaction, if there is hydrogen plus chlorine is written, in that case hydrogen symbol molecular formula you have to write H2 and that of chlorine Cl2. Why? Because they are the diatomic element. Okay. So, that is the difference there. Now, molecular formula, the symbolic representation of molecule of a substance is called a molecular formula. This is the definition. Okay. The symbolic representation, symbol, by using the symbol of the element which are involved in the formation of the molecule, if we represent with them, by them, with the help of them, that is known as the molecular formula. So, some examples of molecular formula is shown there. So, you can read there, the like sodium chloride NaCl, calcium hydroxide CaOH whole 2, how it is formed we have discussed just now. Now, copper sulphate, ferrous sulphate, like that. In next slide. So, for knowing the for doing molecular formula, we should know the valencies of different radical, because we know that in the formation of molecule there is involvement of positive radical as well as negative radical. So, we should be aware about that. Okay. So, which we have already discussed. So, next slide. So, same thing it is there. So, carbonate, all these radicals are mostly involved in the formation of molecule, which we will study in our course. So, these are the major element or radicals, we can say these are the radicals which are involved in the formation of the molecule, okay, which I have already told there is involvement of positive radical and negative radical in the formation of molecule. Okay. Next slide. So, how we can write the molecular formula? Just it is there. We can write a molecular formula using a crisscross method. Step 1, the symbol should be written. Electropositive radical should be written to the left and electronegative radical should be in the right side. The valence is written on the right top as a superscript. If the radical is a compound radical, then valence is written outside the bracket, like example Ca2 CO3 whole 2, okay, like Ca2 CO3. So, in step 2 what we have to do? We have to do exchange the opposite radical. So, just a radical it has moved by place, okay. We will understand again tomorrow. And next slide, in step 2 we have to cross, okay. So, tomorrow after studying this we will prepare this chart, okay. You will practice this. For today you have learned what is the molecular formula, what is molecule, and what are the difference between the H2H and 2H, about that also we have discussed, and we have tried to find out the molecular formula of different element, okay, different molecule, how it is formed. So, we have studied. So, again tomorrow we will go in detail of different radical with their name, their molecular name, how is the molecular name is given. So, about that we will discuss it tomorrow. For today this much. Okay, thank you, stay home, stay safe.